I wanted to just kind of look at your data that you had. I apologize. I've got my neighbors mowing. My windows are open, so it might be a little raucous in the background. Um, on the left side is your data, and I just wanted to verify it. I probably could have just let my own data, but I decided to just try to match yours. Ultimately, I wanted you to see something. When you sent me your data, your graphs, what you ended up giving me was a graph that didn't show 0, 0. And so it made it look, when you zoomed in, it looked like a square root relationship. So when we put 0, 0 in there, we look at the slope, and you've got a slope of 4.2 times 10 to the negative third. So that's 0.004. When I did the data, I got 0.002. So we're pretty close. And if you think about it, for slope, that's pretty flat. Okay, and what does a flat line look like or tell you about the data? It should say there's not much change or influence. This line has an intercept of about 1.1 on yours, and mine has about 1.15, maybe 1.2. And so it looks like the period is pretty consistent of 1.2 seconds. When we look at your data a little bit, just take a look at the percent difference. What I did was I calculated the difference between the average 1.238 and 1.1 calculation, right? And then I took that difference and divided it by the average. So what was the percent difference from the average? And ultimately, when you look at your graph, that first one at that period for angle 2, definitely it looks like an outlier, about 11%. But everything else, right, if we look at it, is under 10%. Now, I know that doesn't seem too consistent. So I went, and that's why I wanted to verify. So what I did is I redid the data and looked at the angles. I might have had a different length and mass, uh, so that might throw things off a little bit because I didn't have that data. But ultimately, we got about the same period. So I might have gotten lucky and gotten the same ones as you did as far as the length. But when I do my differences, my max difference is a 5%. Okay, and remember, if we think about differences in significance, it's that 5% range. So when you're in the 11 and the 8s, it might feel significant as far as a difference. But ultimately, what we want to do is make sure 0, 0 is plotted, and then we look at that slope and we look, it's pretty horizontal, meaning that 1.2 is pretty consistent throughout your investigation. So I just wanted to do that. If you zoomed in and you just plotted from 1.0 to 1.5, you'd see a significant difference, just like you did on your email, right? Yeah, it looks very significant, but you're from 1.1 to 1.3. That's a zero point 0.2 difference, right? So you are zoomed so tight that it's going to look like there's an intense slope or slope change. So make sure when you graph your data, make sure that you're graphing 0, 0 to make things make sense, okay? Uh, so I will go in and update your grade for this. I just wanted to give you some uh, verbal comments to go with it and a video, okay? So I hope that helps. I know I'm being picky, but I really want you to grasp onto that as you close out this physics class. You might never, ever want to take another physics class again. Actually, I think the direction